welcome to EGM722, Week 1, Part 4, Functions. So what is a function? Well, it's a named sequence of statements that performs a computation. So this is something that takes in something called an argument, sometimes. It sometimes returns a result. If it returns a result, it's known as a fruitful function, so it's something that bears fruit. And if it doesn't return a result, it is known as a void function, and it returns something called a none type or a none value. And this is corresponding to null that you might be familiar with other programming languages. So this is not a string none, this is an actual value called none. We've seen one example already, type. So this is a function that takes in an object as its argument, and it returns the type of that object as its result. So why bother writing functions? What's the point? Well, for one thing, it makes our code easier to read. It also helps us to eliminate repetitive code because there are going to be lots of things that we need to do multiple times. And as a general rule of thumb, if we're doing something more than once, it's a good idea to write it as a function. This helps to make, again, the code more readable. But it also means that when we go to fix aspects of our code, so debugging or troubleshooting, we can debug one part of the code at a time. We can also update in a much easier way, because if we have repetitive code where we've copied and pasted the same sequence of statements over and over again, if we need to fix something, then we need to find everywhere that we've copied and pasted that code and fix it in every single one of those locations. If we wrote it in a function, then we just have to fix it in the one place, and everywhere that we call the function, we're now calling the fixed or updated function. We can also reuse them in other scripts. So if we're writing something for one particular analysis and we want to use it in a different one, then we can use that later on. And it becomes much easier to do that if we are writing functions. So if for no other reason than just pure laziness, functions are a good idea. But there are lots of other reasons besides laziness that we want to use them. So the way that a function works, the names for functions follow the exact same rules as for variable names. So we can't start with a number. It has to start with either an underscore or a letter. It can't contain prohibited characters, and it shouldn't overwrite built-in types or specific or protected keywords. The first line of the function is something called a header. We saw this with conditional statements, and here we are starting with something called a definition statement. So we have this DEF, then we have the name of our function, then in parentheses the parameters that we are feeding or that we are going to use in the function. This can also be empty if we have no parameters to use. And then we have the header ending with a colon, just like we saw with the conditional statements. The body of the function definition is indented in exactly the same way that we saw with the conditional statements. So this is how Python typically reads this sort of construction, is that we have an indent, and then once we get to a line that isn't indented, we are sort of out of that whatever construct we were in. It's good practice to write something called a docstring or a document string that tells us a bit more about the function. So what it does, how to call it, what the different parameters are, what the default parameters are, and so on. We can also call functions with arguments, like I said, or not, depending on how we're using them. So these are things that we can keep in mind as we're writing functions. And a parameter, I've used this word without really explaining what it is. So parameter is just a variable that has an argument to a function that is assigned to it within that function. When we're calling a function and we include arguments, they can either be keyword arguments or positional arguments, as I said. Most of the time, the arguments are going to be identified by position, so they're also known as positional parameters or positional arguments. Sometimes they're going to be identified by keyword, so they're known as optional or keyword parameters. And if we look at the docstring for print here, you can see that this contains a little explanation of how we can call the print function. It has a little line about what the print function does, and then the optional keyword arguments. So you can see here that there's a positional value or values that we can input to print. So as long as there's no keyword attached to these are going to be printed by the print function. Then we have the keyword arguments such as sep, which is telling us how, or telling the Python interpreter how to separate the different values when they are printed out. The default is just white space, but you can change that however you like. We can also choose how to end the line when we print. We can also choose to output to a file or to keep it printing to the terminal. So these are different arguments defined in different ways and used in different ways when we're calling a function. I mentioned in one of the previous lessons something called methods. So a method is a function that operates directly on an object. So some examples here for a string. You see here we've defined a string called myString, which has a value the parrot is pining for the fjords. And you see a number of different methods. So these are taking the form of whatever the variable name is, dot, and then the name of the method or the function name. So here you see that one of these called lower just returns the string object, but where all of the text is now in lowercase. The method called upper does the opposite, so now everything is in uppercase or shouting at you. Split is another one, another fairly common one that you'll see and use, which just splits the string on a particular separator. The default is on white space, so we see here that we just get each of the different words in the original string. We can change this default separator in the same way that we saw with the print function, so you can get some information about this by typing help and then in parentheses str.split, and that'll explain to you what split does. If you're in the Python interpreter, you can also search the documentation that I linked in the beginning of the lessons this week for more information. So the last concept that we'll talk about this week is something called scope. So within our functions that we're defining, the variables and parameters that we're using exist in something called the local scope of that function. So they're also something known as local variables. So when the function finishes, these local variables are forgotten by the interpreter. They no longer exist and we can't access them. So if you look at the example here, we defined a function called spam, which just assigns a value of delicious to eggs. So we run the function, it does its thing. If we try to then access the variable eggs, it doesn't exist because it doesn't exist outside of the local scope of this function. If a variable exists outside of all functions in the code, then it exists in something called the global scope. And these are also known as global variables. Generally speaking, code in global scope is not able to access anything in the local scope, as we can see here. So anything that is within this function is not accessible to the interpreter or to the rest of your code unless you explicitly return it and assign it within that global scope. On the other hand, local scope or functions can actually access variables from global scope. So if you see here, we've defined a function again called spam, and here we're just printing the value of eggs. We now assign the value of delicious to the variable called eggs, and when we run spam, it prints that value to the screen. If we then print eggs, you see that it's the same thing. So this is showing us that the function is actually able to access the globally defined variable, but we're not able to go the other way. So technically, what this means is that we can use the same variable name in multiple scopes, in much the same way that we can technically clone dinosaurs. That doesn't mean that it's a good idea. As a general rule, we don't want to do this because for one thing, it very quickly can get confusing. It makes debugging much more difficult because we're no longer sure which value or which particular instance of a variable we're seeing when we're trying to debug the code. So we want to avoid using the same variable name in different scopes. And fortunately, when we're using an integrated development environment such as PyCharm or Spider, these different IDEs will often yell at you when you are doing something like using the same variable name in multiple scopes, because it's something that can cause problems and it tries to get you to avoid doing that. So I mentioned docstrings and help, and I said that this is good practice to include docstrings when we're writing functions. On Blackboard, I've included a few links to some different style guides to help you write docstrings, because this is something that I want to see in the code that you write and submit at the end of the module. So docstrings, again, describe what the function does. So here this is a function called reproject geometry, which is going to reproject a geometry object from one coordinate system to another. We have a number of different parameters for this. They're all positional parameters. There are no keyword parameters in this particular function, and you can see that we have a parameter called source data, which is the geometry object that is going to be reprojected, and then the coordinate reference system for the source and destination coordinate reference systems. So the coordinate reference systems that we are going from to in this reprojection. And then we also list the different types that are accepted for these different parameters, and then it also tells us what the function returns. And then you can see the rest of the body of the function here. So when you're writing docstrings and you include all of this information, future you, as well as anyone else who comes to look at your code, is going to thank you, because it's now very clear what this program or what this function does, how to use it, and what you're able to pass to it. And also, when you call help, the help function is actually reading the docstring of the object. So you can see here that the docstring that I've displayed up here in my programming environment is displayed to the screen when I call help on that particular function. So if we have not written a docstring, then it's not going to give us any information about what to do. To sum all of this up, Functions are a very useful way to help us clean up our code, help with debugging or rewriting our code, and also reusing our code. So they're ways to help us be a little bit lazier as programmers, so that we don't have to spend quite so much time tracking down each instance of a statement that we've written and reused. We also cover the concept of scope. So remember that variables in Python have a scope. It can be either local or global. And when we're writing our functions and our code in general, it's really important to document it so that we can share it with others, and also we don't come back a few months from now and wonder what the heck we were doing. So that's all I have for this lesson. I hope that you found it interesting and useful, and if you have any questions, please don't hesitate to post them in the discussion forum on Blackboard. Thanks. Bye.